Imagine your office orders one large delicious pizza, but 10 hungry people all want to eat it at the exact same time. If one person grabs the whole pizza box, everyone else is left standing in line waiting and hungry. This is a classic resource bottleneck. But what if we could divide that pizza into perfect slices so multiple people can eat simultaneously? That's the core of GPU slicing. That's exactly the problem we solve with GPU slicing in Kubernetes. Let's dive into how we make hardware serve more people efficiently. In a standard Kubernetes setup, when a pod needs a GPU for training a machine learning model, it usually requires an entire card, even if that application is lightweight and only uses 20 or 30% of the GPU's power. The scheduler allocates the whole thing. The remaining 70% of that expensive GPU power just sits there, idle and wasted, while other pods are stuck in the queue. It's like booking a whole 50-seat bus for just one passenger. It gets the job done, but it's incredibly inefficient and expensive. GPU slicing changes the game by logically dividing one physical GPU into multiple smaller independent GPU resources. Think of it as creating virtual partitions. You can take a single GPU and split it into four equal 25% slices. You can even create smaller fragments depending on your specific needs. This gives you granular control over your hardware. Now, instead of one pod hogging the entire cart, you can have four different AI workloads, each receiving their own dedicated slice. They all run on the same physical hardware at the same time, but they are completely isolated from each other. This transformation allows your infrastructure to handle much higher density, maximizing every watt of power and every dollar spent. Let's look at this in a real world production environment to see how it really impacts your day to day operations. You might have a simple chatbot and an image classification service. Neither of these require a full high end GPU. Add in a recommendation engine and an OCR service, and suddenly you have a diverse set of tasks sharing one resource. Instead of buying four expensive GPUs, one single card can serve all four of these applications at once, saving you a fortune. This results in significantly higher utilization and drastically lower infrastructure costs, allowing you to scale faster. So, how does Kubernetes actually handle this behind the scenes? It starts with the Kubernetes scheduler and specialized drivers. Technologies like NVIDIA MIG allow the hardware itself to be partitioned into independent instances with guaranteed isolation. The scheduler sees these slices as distinct resources. A developer can specify a request for a GPU slice directly in their manifest. The scheduler then intelligently places that pod on a node with an available slice, ensuring no resource is left behind. This automation makes managing complex AI infrastructure far more efficient, giving teams better control over their budgets. Now, you might wonder, isn't this just regular resource sharing? Well, not exactly. There are two main ways to share a GPU. Standard time slicing lets pods share the GPU over time, like a revolving door, but multi-instance GPU or MIG provides hard physical walls. MIG ensures that one pod's memory usage can't crash another, providing guaranteed quality of service that is critical for production AI workloads. Enabling this in your cluster is straightforward. It usually involves installing the NVIDIA GPU operator and configuring your node policies. The GPU operator automates the installation of drivers and partitioning tools, making it easy to turn a standard node into a sliced node. You can set your MX strategy to mixed mode, allowing one card to host slices of different sizes tailored to each application's specific needs. Once configured, Kubernetes automatically discovers these new resources. Your node will now report available slices just like they report CPU or memory. Finally, observability is key. You need to see how your slices are performing to ensure your cluster is running at peak efficiency. With tools like Prometheus and Grafana, you can monitor individual slices, tracking memory usage and compute cycles in real time across the cluster. Monitoring allows you to set alerts and detect issues before they impact performance, ensuring your sliced environment remains healthy and scalable. And that is GPU resource slicing, the secret to better utilization, lower costs, and running more AI workload easily. If you found this helpful, follow for more Kubernetes concepts. I am Jitesh Powankar, helping you master the future of DevOps. Check out our AI Agents for DevOps playlist for more deep dives. Thanks for watching and happy scaling your AI infrastructure. See you in the next lesson where we'll explore even more ways to optimize your cloud native workloads. Stay curious and keep building.